All right. So two motorcycles approach each other on the same road. One has a constant velocity of plus 18. So here are some clues. This is the plus direction. This is the negative direction. So the velocity of this motorcycle is plus 18 because it's going this direction, right? So this will be a positive 18 meters per second. The other one is negative 14, and that would be this one because that's going in the negative direction. And so then if we start the clock here, my initial time is 0 here, and this one has the same initial time, 0 seconds. The question is, how long would it be until they meet up, right? Oh, and the total distance, D, is equal to 750 meters. And so this is an interesting one because you're going to have the distance of 1 plus the distance of 2 has to equal 750 meters. Now in this particular case, notice that I said distance and not displacement, because this V2 is going to be displaced a certain amount in the negative direction. But if I subtract that distance from the 750, it's going to be wonky. So what I have to remember is to take the absolute value of this distance, because that displacement would be negative. And I don't want negative. I just want the distance of 1 and the distance of 2 to equal 750. So then I have to also remember, and this is basically the same problem, that our distance formula is always V1 T1. So now this is the tricky thing. So I'm going to say V1 T plus V2 T, but I'm going to take the absolute value of this one. Okay? Has to equal 750. And so, actually, technically, I could probably, because the time would be the time anyways. And so whenever you take the absolute value of something, you have the absolute value of anything inside the bracket. You have two possible solutions that go inside the bracket. We could consider the negative value for x. In other words, this would be the same as what we call the principal or positive. And so when it comes to this, what we're really going to do is we're going to think about V1 times t plus the absolute value of the velocity times t. Now notice that I'm not writing t1 and t2 because they're going to have the same time, right? I have two motorcycles. I start the stopwatch. When they meet up, they're going to be traveling the same time. So in this particular case, T1 is equal to T2. And this is Ti like the initial, and this is Ti like the initial. So I'm just going to make them equal to time because it's easier algebraically. So now I just plug in the velocity. So I have 18. Oh, that's a horrible 8. I have 18 times t plus the absolute value of this, which is 14 times t, is equal to 750 meters. And so when you add those up, you have 18 plus 14, which is 32. And I should probably put in there because it's the speed. It's 32 meters per second times t has to equal 750 meters. Okay, so the trick to this question is there's no written rule that says I have to consider the absolute value. If you plug in the negative number and you do a negative displacement, you get a different answer. So anyways, we chug along. We're going to have to divide by 32 meters per second on both sides. And remember, we're going to reciprocate the meters per second, so the meters cancels with meters, and then the seconds gets tossed up to the top. This all cancels, and so I get the time is equal to 750 divided by, what was that, 32? Yeah. So if I say 750 divided by 32, I get 23.4, roughly. Right? So I get 23.4. And that's your final answer. So that's the hard part about physics, because I'll say that you have to think of displacement, but sometimes you have to like think of distance, and there's no cookie cutter recipe that says, oh, you have to use displacement here and you have to use distance here. Did that make sense after I explained it? No, that's why we need practice. We need to do 27 of these problems.
So the answer is B?
Yeah, it's about 23 seconds.
Can you do 8 and 9 too?
I can do 8 and 9. Let me finish this one and post this real quick.